use are summarized in the succeeding tables and discussions. In both municipalities, most farmers use insecticides, fungicides, and weedicides. Based on the percentage of respondents, more Bugyas farmers are varied pesticides as compared to those of Kapangan. Some also indicated the use of rodenticide. Most respondents applied pesticides as needed or every 3 days or every week. To protect themselves, most farmers use boots. More respondents from Bugyas practice the wearing of gauntlet gloves and coveralls, while more Kapangan farmer respondents wore face masks and goggles. The data also show that very few farmers use more than one type of protective clothing. There were a total of 41 farmers who reported not using any protective clothing at all. A higher percentage of farmer respondents from Bugyas have been using pesticides for more than 20 years as compared to Kapangan respondents. The majority, however, have used pesticides for less than 10 years. Almost all the pesticide users employ the knapsack system. They further reported that they perform the 3 pesticide-related activities, namely mixing, loading, and spraying, where they experience spillage on various parts of the body, mainly the hands, arms, and the back. The findings also show that farmers learned about pesticide use from informal talks, seminars, and printed materials. Pesticide residues in soil. The environmental fate of pesticides in the soil is viewed with great concern. It has been calculated that 50% of the pesticides sprayed on crops or used as herbicide misses its target and falls onto the soil. Some pesticides, notably organochlorines, may persist in the soil for years, even though a large proportion evaporates. The persistence and transport of pesticides in soil depend on several factors, such as the chemical structure of the compound, type of formulation, type of soil, weather conditions, irrigation, type of crop, and microorganism present in the soil. Pesticide residues in water. Water samples were collected from the same sources as the soil and vegetables used in the study. All samples were analyzed through gas chromatography for the presence of pesticide residues. No pesticide residues were detected from all the water samples at the limit of determination, which is lesser 0.03 mg per kilo for organophosphates and lesser 0.005 mg per kilogram for organochlorines and pyrethroids. Pesticide residues in vegetables. Quantitative analysis using gas chromatography was used to determine the concentrations of the pesticide residues in the selected crops from Kapangan and Bugyas. The concentration is then compared with maximum residue limit, which is the quantity of residues considered safe for human consumption. The maximum residue limit are usually used by the Codex Committee on Pesticide Residues in setting maximum residue limits for pesticide residues on commodities in international trade. Based on the results given, only one vegetable sample was identified to contain a pyrethroid residue, cypermethrin, with a quantity of 0.30 mg per kilogram. Since there is no MRL for cypermethrin in petchay, it cannot be determined whether this amount is beyond the safe level for human consumption. More residues were identified from the crops collected from the Bugyas municipality. Out of the 9 samples, 5 were tested positive for residues at limit of determination. However, only one sample contained an organophosphate residue with a quantity of 0.37 mg per kilogram higher than the MRL of 0.05 mg per kilogram. As there are no MRL values for cypermethrin and profenophos in celery as well as fern valerate and chlorpyrifos in petchay,